the last video I said we're doing inventory cost. I forgot this one was in the next part of my notes. All right, so this one and then inventory cost. This is actually a simple application. I don't have to set anything up. This is actually the easiest of the bunch. Suppose I have this information. They've modeled the speed of a highway by the S of t function. So S of t gives the approximate speed. So what on average most of the cars are traveling at a given time. Alright, so it's modeled by that cubic function. Over the hours of noon to 7 p.m., so from 12 p.m. to 7 p.m., so the domain for that, so the function only models the traffic flow between noon, which is time 0, and 7 hours later, which is 7 p.m., the start of the 7 p.m. hour. Alright, so they gave me the domain, so I don't have to find domain. They told me 0 to 7 is my domain, and it stands for 12 p.m. to 7 p.m., and everything in between. Alright, at what times is the traffic average speed the slowest and the fastest? So this time I want both. Alright, I am going to find both. And so I do need to use the closed interval case. I can't use the open interval case, because my 0 and my 7 could be when I'm slowest or fastest, right? My endpoints. Verify and then give the answer. So I'm going to do my work down here. So first thing, I need to find any critical values on the domain 0 to 7. Alright, so which means I need my derivative and set it equal to 0. Alright, so my derivative is 3t squared minus 18t plus 15. Set it equal to 0, and I'm going to go ahead and factor out the 3 when I set it equal to 0, right? I can divide a 3 out of 3, 18 and 15, so that's what I'm going to do. When I take it out of the 3, it's just going to leave me with a t squared. When I take it out of my 18, it's going to leave me with a negative 6t, and 15, it's going to leave me with a positive 5. Which means it's going to be much easier to factor, right? Because 5 is a prime, t is just t times itself, and I get negative 5 and negative 1, right? Negative 5 times negative 1 will give me my positive 5. Negative 5 plus a negative 1 will give me my negative 6. Alright, so I get two values, 1 and 5, and since it's the closed case and they're both in my domain, I keep them both. Right? They're both, there's 1 p.m., it stands for 1 p.m. and 5 p.m. That lands between noon and 7 p.m. And so the test in this case, well, it's the closed case. And so the test is just, well, once I've got all my values and my endpoints, I just plug them into the original function. So I'm going to find the speed at 1. I'm going to find the speed at 5, my criticals. And then I'm going to find the speed at time 0, which was noon. And I'm going to find the speed at time 7, which was 7 p.m. And so I'm plugging all of those in. I'm finding the y values. I'm plugging them all into my original function, which was t cubed minus 9t squared plus 15t plus 15. It was in miles per hour. So all of those are going into that equation. Alright, so when I plug 1 in, I get 57 miles per hour. When I plug 5 in, I get 25 miles per hour. 0 is 15 miles per hour. And 7 comes out 57 miles per hour. Alright, so maximum is 57. Minimum is 25. 50 is just somewhere in between max and min. And so there's my answers. So the maximum speed that the highway gets on average, wherever it is, during the time noon to 7 p.m., the fastest occurs at what times? 1 p.m. and 7 p.m. Alright, so the fastest is at 1 p.m., or the 1 stands for 1 p.m., and 7 p.m. There's 2 times where it reaches its fastest. Its fastest speed is 57 miles per hour. So on average, at 1 p.m. and 7 p.m., the cars are flowing at an average speed of 57 miles per hour, and that's the fastest during that time frame. The slowest was 25 miles per hour, and that happened at 5 p.m., which would be right around rush hour. All right, 5 p.m., the traffic slowed down, a traffic jam, and it slowed down to an average speed of 25 miles per hour. So on average, the traffic, this particular region, is the speed of 25 miles per hour. All right, so that was an example of where you get both of them. right? We have both max and mins. In that case, it's the closed interval case, and I do have to use the closed interval method, right? The first method we learned. All right, we'll stop there. Last thing, finally, we'll get to the inventory cost. So again, make sure you've looked at the inventory cost, because I'm just going to do a couple more additional examples to what the MyLab does. Stop there, maybe.